example 2, this one is a little bit different. It says simplify each rational expression and state the non-permissible values. So we have to state our non-permissible values, but we also need to simplify. So non-permissible values, you factor your denominator and you look at that only. But for simplifying, we are going to factor both the numerator and the denominator. Just cut my word off there. Okay, factor both the numerator and the denominator. And then you can cancel any factors that occur in both the numerator and the denominator. And I kind of want to use the word proportionally, but I'm not sure if that's going to mean the same thing to you as it does to me, so I'm going to explain that. So cancel any factors that occur in both the numerator and denominator. It's a 1-for-1 ratio. So if I have an x plus 2 in my numerator, and I have an x plus 2 in my denominator, I can cross off 1 on the top and 1 on the bottom. But if I have 2x plus 2 somewhere, I can't like cross off 2 in one spot and 1 in the other. It's a 1-for-1 ratio, or 2-for-2 ratio, okay? So let's take a look at this first one. We have 3x minus 6. So how do you factor that one? The order's fine. The greatest common factor is just the number 3. So when I pull that out, my leftovers then would be x minus 2. Okay? That one is just simply a greatest common factor. That's all there is. In the denominator, we can't look at factors of 10, negative 10. We're going to be looking at factors of 2 times negative 10, so negative 20. And they need to multiply together to get a plus 1 in the middle. Okay, so that's going to be 4 and 5. And I want my 5 to be plus because I need more positives. Okay, now, when it comes to factoring, if you're somebody that splits it down the middle, I suggest you don't do it in your denominator. I suggest you do it on the side, and then you only put the result over here because it gets too confusing. So that's what I'm going to do. 2x squared plus my x minus my 10. I'm going to use my little factor tree there to split my middle term. So the first one stays the same, 2x. The last one stays the same, minus 10. Okay? And then, 2x squared, I missed that. Thank you. And then the middle one is going to be minus 4x and plus 5x. I just split it down the middle, and my middle sign goes with the right-hand side. The first side, I factor out the greatest common factor, which is 2x, and I have left an x minus 2. The second side, I pull out the sign that's there in the middle, and the greatest common factor, which is 5, good. And my leftovers there would be an x minus 2. I know I've done it right because my two little leftovers in my brackets here are the same. So that's one of my factors, x minus 2. My other factor is the greatest common factors that I pulled out of each side, so the 2x and the plus 5. Okay, so I do all that work on the side, and now I can put that back in here. An x minus 2 and a 2x plus 5. Okay? And now when you look at this, I've factored both my numerator and my denominator, and now I can cancel any factors that occur in both the numerator and the denominator. Well, that's the x minus 2 and the x minus 2. So this expression is now just a 3 over a 2x plus 5. Okay, now, I will tell you this. We did not change the value of it, even though we don't know the exact value right now. If I put in, let's say, an x, that's 10. Okay, so say I put in 10 every time I see x. If I do it in my original equation, I'll get a certain fraction. But if I do it here, in my simplified version, I'm going to get the same fraction. Okay, it's just that I've already reduced it. So it's no different than if you said, okay, 4/8 versus 1/2. It's worth the same amount, it just looks different because you've simplified the numerator and denominator. Okay? The only thing I have to be careful of here is my non-permissible values. Lots of times I'll just put a comma afterwards. X cannot equal, and I'm going to put mine underneath because I didn't run out of room. But usually you just put a comma and you put it beside. X cannot equal. Now, if you look here, my denominator, this guy was already factored, my 2x plus 5, okay? What's the non-permissible value that comes from that? So pretend it's not allowed to be 0, move the 5 over, move the 2. What answer do you get that x is not allowed to be? Negative 5 halves. Good. Now, here's the trick. That's not the only one. So, the reason why it's not the only one is you crossed one off, but you have to pretend it's still there. So the one that you crossed off was x minus 2 as a factor. So what non-permissible value does that one give us? X can't be 2. Okay? So now why do I have to list both? Well, this original expression is supposed to be exactly equal to this one here. They're supposed to be worth the same amount no matter what x I put in. If I put an x of 5 up here or an x of 5 here, it should give me the same fraction, just reduced. Okay, so if I wasn't allowed to put a 2 in the original, then I am not allowed to put a 2 in the bottom, because then I'd have one more extra number that I'm representing that wasn't actually one of the original numbers. So your non-permissible values, you might want to put this over here when you go to simplify. Your non-permissible values come from